Okay, this is a second video on differentiation, and this time it looks at the application to velocity and acceleration. In the previous video, we explained that dy by dx gave the change in y in relation to a change in x, and that's why it gives you the gradient. Similarly, ds by dt would give you the change in s in relation to a change in t. Now, if s is displacement and t is time, then ds by dt will give you a change in displacement divided by a change in time. And we know that to be velocity. By definition, that's what velocity is. So if s is displacement and t is time, then ds by dt gives you the velocity. Similarly, if v is velocity and t is time, then dv by dt will be a change in velocity divided by a change in time, and that is what we call acceleration. So that's the application of differentiation to both velocity and acceleration. Here's our first example then. We're given an expression for s, the displacement of an object. Part A says find the displacement of the object after 2 seconds. So quite simply, because it requires a displacement after 2 seconds, we put t equals 2 into our expression for displacement, and that gives us 25.6. Now in part B, we're asked for the velocity. Now we're given the displacement, and the velocity is obtained by finding the expression ds by dt. That means we differentiate our expression for s in relation to time. So 4.9t squared becomes 9.8t. We bring the power down to the front, so it's 2 times 4.9, that's 9.8, and we reduce the power of t by 1, so t squared becomes t, and 3t just becomes plus 3. Now we want the velocity after 3 seconds, so we substitute t equals 3 into our expression for velocity, and that gives us 32.4, and the units are meters per second. Here in example 2, once again, we're given an expression for the displacement. Part A wants the initial velocity. So once again, we have to differentiate s with respect to t to obtain an expression for velocity. And that's the expression we obtain. When t equals 0, we want the initial velocity. So t equals 0, we substitute that into our expression for velocity, and that gives us 5 meters per second. In part B, we want the time when the object comes to rest. Well, something comes to rest when its velocity is 0. So we want ds by dt to equal 0. So we put our expression equal to 0, and that gives us a value of t of 0.5102. So that's 0.510 seconds to 3 significant figures. Now we're applying differentiation in order to find acceleration. Now remember, acceleration is the change in velocity with respect to a change in time. So that expression is dv by dt. So in this question, we have an expression for velocity, and we need to differentiate v with respect to t. So when we differentiate that expression, we obtain 2t subtract 3. If you're not sure where these expressions for the differentiated expression comes from, then I suggest you look at the previous video on differentiation. It goes through that in more detail. When t equals 3, we want the acceleration after 3 seconds, so we substitute t equals 3 into our expression for acceleration, and that gives us 3, and the units are meters per second squared. In part B, we want the acceleration, the time when the acceleration is 0, so we put our expression for acceleration, which is 2t subtract 3, we put that equal to 0, and that gives us 1.5 seconds. And in example 2, once again, we're given our expression for velocity. We want the acceleration, so we need to differentiate that expression for velocity with respect to time, i.e. we need to find dv by dt. And when we differentiate that expression with respect to t, we obtain 4 subtract 6t, so that's our expression for acceleration. And the unit's meters per second squared. And then in part B, velocity is at a minimum. Now, if we think back to our first video on differentiation, a maximum or minimum for y was obtained when dy by dx equals 0. Therefore, a maximum or minimum for velocity will be obtained when dv by dt equals 0. Therefore, we differentiate the expression, put that equal to 0, and that gives us t equals 2/3. So, a little recap on velocity and acceleration with regards to differentiation. ds by dt gives us an expression for velocity. dv by dt gives us our expression for acceleration. Initial velocity means the velocity when t is 0. When something comes to rest, it's stationary. That means the velocity is 0. And a maximum or minimum velocity occurs when dv by dt equals 0.